recording. Okay, so that was all about the count plot. And so about your question, Anirudh, is it like which libraries you are not able to install? Can you just post them here? No problem, Rahul. So for week 6, which libraries? Okay. Okay, so I think you should install with a different which uh, command you use for installing it, because this error is new. Actually, there is problem with the API for like 1 year, so we have been facing problems. I was resolving queries when I was on the Q&A flat platform as well. So um, I know there are a lot of problems in this, but not everyone faces it. So it usually depends on how you have installed it. So what you can do is, for example, if you have installed it using pip, then you can actually you should have installed it using pip 3, because if you haven't, you can first update your pip and then install. So first try doing this, like after doing updating the pip. Otherwise, which I'm not sure which one is the correct version, but it is like you did pip 3 and it is still problematic, but it is not installing. Okay, what is the error? I think it would be saying that pip 3 is not available. So you installed pip. So after that, did it install this? After updating the pip or installing the pip, was you able to do this? And still it is giving you the error. So I haven't seen this error. I will actually come to your error after looking at it in detail after in the break, and I will come back to the answer. Actually, there was another issue. Actually, so it's just a warning. Someone mentioned that it is just a warning. Okay, so see if it is just a warning for you, then okay, it doesn't matter, because there. Let me read it again. Uh, okay, this is unstable API warning. So have you tried using it further, like after getting this warning? But the only issue which can occur is like the date problem. Actually, when you start to pick up from this date, it will just give you like the latest dates from 2016, I think, or 17. That was the only issue. And actually, if we talk about the error, that is the only error which can occur. So in which you will not get updated dates. So for that, what you can do is I have posted a answer to this problem on the Q&A, and I also shared the link in the session, so you can look into that if you have that problem. But usually if it works fine, so I think there's just one source out of them which gives that problem, which doesn't have the updated API, like last updated API, as it is not updated after 2017. So the last problem which occurred was related to this date problem, which was like it wasn't giving the date after 2016 something. So, and you need for 3 years. So which is the which is also resolvable by doing just one tweak. So you can, if you face that problem, then you can go on Q&A, or you can uh, ask again. But I think the Q&A is a already resolved problem. So okay guys, so okay, so we today are going for advanced pandas part 1. Actually, this will be the same notebook we will be seeing for both sessions. Uh, Itself, these two sessions are for putting you guys in uh, more ways of using pandas. So what we have done so far is, if you want to do data analysis, they are fine. You can just do data analysis, but for what we have done so far. But these are for handling the different type of data sources and how you merge if you have multiple files of same data, like you have your first 100 examples in a different file, and first other 100 examples in a different file, and so on. So if you have distributed format of this data, then how you handle that. And if you have different formats of data, for example, you are picking up the data directly from the database tables, then in that case, how to pick up the data. So these uh, this and the next session will be about how to use pandas in further advanced level. But if you have basic data and you have the data in one file and you just want to do data analysis, then what we have done so far was fine. But now these sessions are all about playing with more or multiple file format data. So let's come to that. And we usually have the data in like mm, a lot of files, so that this is important, how to merge the data frames, how to make a single data frame out of them. So, and there is another thing which we will be looking at is regular expressions, how to use them with pandas. So let's start. And okay, so first we are going to start with merging the data frames. So we will see few ways, like in cat, there is another way, append, of merging the data frames. Actually, this is really important to see concatenation and merging, because sometimes if you are merging two data frames, they will merge, and the shapes of the data frame will be gone out, and there will be no error. So you have always to keep the axis in mind. So this thing is important. So you have three data frames in which you just put some values, and the first data frame is like, if you can see here, that data frame is like that, and then it is continuing from A4 for the second, and the last one goes from A8 to A11. So these are the values, and you have three data frames for the with the four rows. Concatenation is simple, and axis by default is 0, which means it will be row wise in this direction, and uh, you just use pd.concat, and you give a list of data frames. So this is a list of data frames. Here, this is a list of data frames. If and as it is row wise, so it will concat in this direction, and as the shape suggests, it is like 4 columns, and number of rows doesn't matter because you are just concatenating below. So these are concatenated like this. So the resulting data frame comes like a single data frame with 12 rows. So another thing which has to be uh, seen here is like the order is like what is the order of data frames, and this can be this way of picking up the data and putting in together is can be taken for number of files, and your list can be a list of 100 data frames which you haven't written yourself, just you you put a loop over the files you were reading the data frames, and then you gave that list here. So that's why the list is used for concatenating data frames. The reason of the development reason of using the list is this, that you can put all the data frames together in a single array, and then you can give it to the function. So it is scalable, there is no limit, you can put as much as data as your memory can hold. The other thing I was talking about is taking care of the shapes. So the axis one is usually like the columns, so that's why you have the repetition of columns and you have nan values because you didn't concatenate in the right way. So first, the suggestion is like you just print the head of your data frame, and then you look at it that what is the format of the data frame, and then concatenate. Sometimes your data may come like in this direction, but usually in pandas it doesn't happen. So you always know that, but how you have picked up your data. So because in pandas you already have column names in the files, or sometimes you don't have them, so you specify them, but you always know the form of data. But when you are dealing with just the numerical data, you sometimes your data is in the row or column format. It can be differentiated. So let's come to the another example in which you have two data frames. The first data frame is about, I haven't put it pandas, of course. Okay, so first data frame you have students, and their IDs, and then you have a marks data frame in which you have the courses and their marks. So you are concatenating them. The problem with this concatenation is that the order should be same, because if you see there are two data frames, if I just print them both, you will be able to see them. This concatenation makes sense only if the order is same. What's the need to concatenate? Okay, that's what I was saying. Like for example, I just take an, for example, you have the data in following format. I will rather say database. This database is not any SQL or just you cannot hear. Just wait a second. I will just answer him. So I have I was where I was. Okay, so to what is the use of concatenate? So for example, you have the database in which you have 1,000 files. Each file contains like 100 rows of data. So what you will be doing is like you will be reading 1,000 data frames for 1,000 files, right? So in this case, these data frames are not together, so you want them in a single data frame. So you will concatenate all these data frames together. Did you get the idea of using concatenate now? So this is one use case of the concatenate. The other use case I am just coming to is like with this example right now. So you see your data is, you can say this format of data is just your data is distributed. Maybe your data is at, for example, if you're on a higher level, maybe your data is on the cluster and you're picking up data from different systems, and then you can merge them together on a master, or you can say in lay term that on a single system, on a single unit. So that's why the concatenate is important. So is it clear? So like you will have 1,000 data frames of for 1,000 files, and you will have 100 rows in each data frame, resulting data frame will have 100 into 1,000 rows, like 100,000 rows. Is it clear or no? I can still explain again. Okay, sure, but there should be some relation between each file, only that. Yeah, of course. They are, for example, the same, the data is like from the same source. The relation you are talking about is like the format of the data is same, but it's not like a relation related to the through the joins we have in SQL, or you have some relation in the columns. Like for example, sometimes we have ID in both files, so we can merge on the basis of ID. It is not like that. It is just the rows of the same data which are distributed among the files. So for example, one chunk of the data is in another file, one in another file, and one in another file. So let's take an example here. For example, we have this data of students, and you have their marks, you have, let's say I say Anirudh, then we have Vishak, I think. Yeah. So you are two students in file one. Your marks are there. So like let's say 40, 40, not out of 100. So let's say other guys are in the other file. Let's say 40, 40, and so this is the distribution of the same data, same type of data among the files. So you don't need any relation other than they being same. So when you pick up the data frame, for example, your first data frame one will be containing these rows, these two rows. The df2 will be containing these two rows, and when you concatenate them, so it will be like 4 rows. So what is happening is that your format of data was same, but what you wanted to do is like your format of data was same, but it was distributed among the files. The same data was distributed among the files. The data coming from the same source was distributed among the files. So what you did was you picked up the data from each file and then you merged it, like you concatenated it together to be in a single data frame, because you want the data to be in a single data structure or data frame. Is it clear now or no? Yeah. So the relation is not necessary. The relation like based on ID or something is not necessary. The only relation which should be there is the similarity of the data format which is there. Okay, so to 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 discuss the same example about the relation, for example, we have this data structure, we have this data frame, and so Ojaz, can you hear me now? No, I don't think so. Okay, I hope he can hear us. What? Okay, what could be the problem? Is it with the GoToMeeting? Someone else faced it ever? Okay, so could be the connectivity issue, yeah. Maybe because of the internet. But still, you should be hearing something like a little bit. Yes, a good suggestion from Ramesh. Yeah, you just try changing the device. If it still doesn't work, then it means that it is of course, a connection problem. So, okay, so let's come back. I hope he could join again. So let's continue, or if he joins, like he can fix his problem soon. So I will repeat it to him again. So Okay, so uh, let's start again. Okay, so we were talking about the concatenate. As here you can see the data structure or the data format is not same, and you're still merging and still concatenating. So you are concatenating because you know that the order of the data which is there is correct. These are the marks for Helen, these are for Jack, and then Sparrow. So if this order is not same, you cannot concatenate because this is really weak way of concatenating the data because you don't have a ID here. Because when you are concatenating the same sort of data, then it doesn't matter because the type of data is same. But in this case, you are concatenating two different types of informations just on the base of order, which this risk should not be taken because this can corrupt your data. I will never recommend you guys to do this because in this format you don't have the ID with this table, so you just have to do it. But suddenly, sometimes you just have to do it. So and sometimes it doesn't happen because you always have IDs in this form of data. So best of luck for your login. I hope it works because it can be really bad if you are there but you cannot hear. So okay, so let's move forward to our the first example, which was this one of concatenating the rows. So the other way of doing is append. The same implementation can be done using append. Append is like if you have df1, you are appending at the end, so you are appending df2 in below, so it will append this data frame too. And if you can even append a list of data frames, so it will, this is again equivalent to what you did before, like concatenate. So just a different way of doing it, but usually append is used when you are just concatenating two data frames, like you're appending again and again. For example, you put append in the loop and you are reading a data frame, you just append it to the previous data frame where you had. So this can be done in that way as well. Or you can just concatenate or append like this at the end. Okay, so that's what we have for data frames. We saw append for list, so it just works like the same way. Now we come to the merge. If we had append, what is the use of merge? So now it comes about relationship between the data frames, relationship between two different data. So there is some noise, I think. So okay, so let's figure out. Okay, so you have two data frames again, but now you have IDs, like you can see here in here that you have an ID and you also have a student data frame and you also have ID. So if we print both, you have IDs and you have some data related to these IDs. So what if we merge them together like before? It will be problematic, right? Because you don't have the same structure of data. Here you have an ID 5 which is not here, so he's a new student. Okay, so in this case what you can do is you can join the data frames. So I think you will most of the guys have the understanding of what join is, but still we will discuss it, like what are the joins. Joins are actually the operations of merging data frames or databases. So uh, we will discuss that in detail. There are several types of data frames of joins. Usually what they are is like, can we specifically pick up a particular row to be appended or concatenated? Yes, you can. If, for example, you just select a row of data frame, and that resulting thing will also be a data frame. So by doing indexing and just appending that, you can do that. For example, you have a data frame one. What you can do is like you can just pick up the first row and all columns. Sorry, actually, you don't need to do this. Just the first row, and you assign it. Sorry, actually, you will be doing this. And just append it to data frame 2. So this will be appending row 1 of data frame 1 to data frame 2. So this is like this. This operation is like for picking up the row and appending. But there is no implementation of like giving it like this, like you are want to tell it in the append function. It is not possible. So okay guys, so joins. We were talking about joins. Joins are like for merging the data frames, for combining the data frames, and joins are in basic terms are measures of combining data, any type of data, maybe in this SQL or maybe data frames. So in general, we have three types: left, right. We will discuss them, and full. Left, right, full, and there is another one. In is it you set outer join and inner. So we will discuss these. So let's say you have, for example, you have these in two sets of data. Let's see it in Venn diagram. So for example, you have two sets of data and you are picking up the data on the basis of IDs. So what will be the effect of picking up of data in in either cases which we have mentioned here? So how it will combine? So when you are combining on IDs, there can be several ways. So if you have this, for example, you have this data frame A and this is B. And there is you can see a certain area which is in both. So this gray area is in like common values, you can say that. So when you do left outer join, left join, what it will do is like it will be containing the common values, for example, the IDs which are in both, and also the IDs which are in A, because the table on the left is considered, the data frame on the left is considered for this, because the order in which you put the both tables that matters. For example, you said A, you called the function on A, and you are putting a second data frame after that. Then the second data frame is on the right side and the first one on the left side. So the order matters. So if you selected the join to be on left side, then it will contain the common IDs which were in both, and all the other data which was in A, and the data for B for corresponding join will be just none. We will see that example there, but right now, just to get the idea, left outer join will be like this. And for the right, of course, it will be like this. Or you can say that if you change the order and apply left join, then it will be the same case. And this is the inner join. So inner join will give you just the data IDs which are in both. So you can say that it is intersection. And full outer join will give you all the data. So the common data and the data for A which is not in B, the IDs of A which are not in B, it will give you those as well, and with none on B, and similarly for none on A when you have the data which is not there in A but in B. So there are four cases. We can repeat. You have a left join in which you will have the values of A which are not in B, and the common values which have same IDs. And the other case is you can have right outer join in which you will have B and the common values. And outer join, full outer join is like this, and the inner join is like this, in which you have the common values only. So now we will see the example and it will be more clear. Okay, so we have this data here, and you are merging on some order. Okay, so let's say you have this data, we have ID to merge. By default, merge has the inner join, so the case is this case, the common values. So where the ID will match, it will be in the data frame. So you are putting student on the left side and marks on the right side, and you are joining on ID. On is for joining on, as in joining on. So you told that you are joining these data frames on IDs. So the relation is based on IDs. So what is happening is, like, you can see you have ID 1, 2, 3 in common for both. So only those IDs will be there. So if I use a highlighter, you have one here, you have one here, you have two here, you have two here, you have three here, and you three here. So in this case, 5 is in the left table and 4 in the right table, which are not in each other. So if I go back and write it down here, like, just wait a second. So let's say we have a bigger group of okay, so let's say we have these IDs 1, 2, 3, which are there, and for example, the student is on this side and marks on the other side, and we don't have which IDs for marks. For student, we don't have the fifth ID 5, which is not in common, and here you have ID 4, which is not in common. So this is the case. So what will inner join give you is the common area is this area, and by default it is an inner join. So you can see that it is only common values. Since after this example we picked up the same student data frame, we and then we merged it on the basis of right join. So the join here is right. So the ID 4 is which is not available in the left table, which is this one. So if we go on this, you will see that ID 4 is in marks but not in students. So we will have another row which have ID 4 marks but none here, because in student there was no ID 4. But as the join is is a right join, then that's why the left, which is student, the left table or data frame which was student, doesn't get to have the ID 5 here, because the join is only right join. So in this case, this data is included. And similarly, if we go for an outer join, ID 5 will be there, ID 4 will be there as well, because for outer join, this contains all the values. And for the left join, it will be opposite to the right join, and it will be like this. So it will be containing this row but not this row. I hope it would be clear for everyone to how to merge on the base of some column. So we will see more examples. So here we have teams, team data frames. One is with the batsmen and one is with the bowlers. So let's say we have let's see the data frames, so we will have more understanding how they are. Let's see. Okay, so two data frames, one for batsman, one for bowler. We want to make them, like, bring them together, and we have several teams. Only RCB and DD are common teams. Even KKR is common. So Mumbai Indian is a team which is not there in this table. So when you merge, of course, what you will get is for KKR, RCB, DD, yes, no Mumbai Indian, because the default join is inner. So after doing this, you will see that we have these merged values. We are merging on the base of team, and now if you merge like with the outer join, you will see that there is a NaN, but for the data frame 1, but there is Mumbai Indian here, so you will see that it is there. So we can also get incorrect results if we use concatenate in this example. So the whole meaning of concatenate is different here, because concatenate just concatenates in the order. So if you follow the order, 0 on the base of index, it is concatenating on the base of index here, 0, 1. So this order is not the correct order, and there is no relationship between the values. So concatenate is just an appending operation, and merge is just like just joins you have basically in SQL. So now you have if the key on which data frame need to be merged don't have same column name. In that case, what you can do, for example, in both data frames, for example, here it is team, here it is team name or something else. So let's see this case. let's see, the column name is different, right? But you want to merge on the same thing. So you will say that you are merging data frame 1 dot merge data frame 2 left on team, basically left join on team, and right join, basically for the right table it is on team name. So rather than saying on, you are specifically telling on right, or for the left table it is on team, and for the right table it is on team name, and you saying that we want a outer join. And you can even put inner join here because it doesn't matter. So this is that does not confuse this with the left join and right join thing. This is just mentioning for the left table which column you want to pick up, and for the right table which column you want to pick up. And then you can of course drop the team name and team columns to make it more beautiful, or you can drop either one of them to make it more beautiful. But you will have to drop both because for the left you didn't have any value for this, so it has given nan for team as well, so you will have to drop both to make it fine, or otherwise you can drop team and keep team name, but you will have to drop both if you want, otherwise you will have to keep both. But it depends on what you want to do, but the operation is applied like this using the column names which are in both. Okay, so let's see merging on multiple keys. So we have been so far what we have been doing is like we have merged on a single key or single key with different names. But now what we want is we want to merge on different keys. Okay, so you have these two data frames in which you have season, batsman and team, and you also have home city in the other data frame and their season and team. So let's see. What you want to do is you want to join on two columns. You want to join on team and season both. So what you are saying is that df1, which is the left table, df2 is the right table, on team and season. How it is supposed to be an outer join. So let's see how it is merged. So now you need to know if the join is outer, then of course every possibility will be there, even for the ones which doesn't have the common factor in both of them. So for 2016 KKR, this is one pair of value. You will see 2016 KKR is here. So Gambhir, Narayan and Kolkata. Gambhir, Narayan and Kolkata. 2015 RCB. 2015 RCB is a common factor. So 2015 RCB has this row. But for the others, 2016 there is no DD. So JB Domini, 2016 DD and Nan because there is nothing here as it is an outer join. And similarly for the other ones here, there is no value here. And in case of inner join, it will be just two rows, the first two rows. So in case if we don't want to merge every column from the second data frame, for example, we right now we are merging, but we don't want to merge everything out of this. So how to do that? Just pick up the columns you want. Like you don't need, for example, or you are saying you don't need home city of the second data frame, then just pick up the other columns and then apply the data frame. So it is not about the merging, it is the same, it is the same logic you do with indexing. So you are doing indexing rather than merging. Okay, so we are good so far. I hope you have questions, so you will be asking them. So let's take a break, and in this break we can have question answers. So you can ask, and I will look into your. But it was resolved, right? Because it was just a warning. So okay, let's have a break, guys, and see if something is confusing related to joins or anything. You can ask. I hope you got the idea of joins, but still, if there is anything confusing, because it can be, so you can ask. So we will have 10 minutes break. Starting again, and let's start. So we saw this topic before in pandas, and okay, no problem. You can ask questions later if you have any. So for the stack, unstack, pivot, melt, we did cover this before. So we will go through like in a good pace through them. So it is not really like a new topic. For example, you have a data frame df in which you have the index as 1, 2, which are strings, and you have columns and ID and value. So what if you stack them? So the stacking will give you a different format of result. Okay. What is it doing? Like you have applied stack on same data frame, so it is giving you two data frames like this. Like for example, you have one, not two data frames. It is like you have sub-indexing. If you remember, you can have multi-indexing. So in this case, you have like one group as this and the other group as this. So stacking will result in this sort of result, but we remember, if you remember, we can reset index to make it plain again. So the reset index will give, like, because as the index was 1, so it will like was strings, so it will also plain this, because reset index just brings your data format data to the format like this, in which you have the indexing as 0, 1, 2, 3. So what is it saying? What is level 0 and level 1? So we will look for it, because level 0 and level 1 are the levels of indexing. So when we did stack, we said that it is doing multi-indexing. So level 0 is this, and level 1 is this. So after doing the reset index, it names it like this. For example, level 0 was 1, 2, and level 1 is ID and value, because if in the multi-indexing it was like this. So this is your first index, level 0 index, and this is your sub index, which is ID and value. So you can say that this is a level 1. So you can consider it like a tree. Like for 1 you have ID and value, and for 2 you have ID and value. So that's why this is level 0 and this is level 1 of, but this whole is an index. There, what is happening is stack is converting it into the multi-index. So how the stack works? It takes the index and the columns and make this multi-index format of the data frame. Let's move forward. After reset index, we will be able to understand this in more detail. That what was the levels? The levels is like, as I discussed, 1 and 2, and level 1 is like the columns which were your second level in multi-indexing. So let's say we have another data frame. We have a series. So in this series we have this as index. So if I divide it using a line, and this is like this. So here, this is your index, multi-indexing, and this is your values. So we can also unstack them. So if we see reset index will just reset the index to 0, 1, 2, like incremental reset index will give you the incremental index using the numbers, and it will give the very previous indexing some levels, which we saw that these are the levels. This is level 1 and this is level 2. So uh, okay, so this is level 1 and this is level 2, level 0, level 1, you can say. But unstack would what unstack will do is like it brings it back to the column and index format. So this column and index format was the one from which you did stack. So A, B, 1, 2. This is the, so it brings level 0 back to the index, and it brings the level 1 back to the columns. What we want to do next is, like, we want to see pivot. Pivot is what we discussed before, that pivoting over a certain column or something. And then you also want to say see the difference of long to wide format. So what pivot do is, like, it converts it to the wide format. This is the long format. This general format of a data frame is the long format. So we have this data from IPL. We will not go in. Okay, just wait a second. Okay, so we have this IPL data set again. We will go in not go in details of what is the group by doing. We will just see the format we have. So we have seasons, we have batsmen and their runs, their total runs in a season. So we want to see that what does pivot do. We have seen it in plotting as well, so it is just again a repetition, as I said. So pivot gives you a wide format. You can see this is a long format. Even from the visual perception, it can be understood that this is a long format and this is the wide format. So what happens in the wide format? You just pivoted on batsman, and you selected the values to be batsman runs, and the index is season. So the your index here is season, and you are making batsman as your columns, and you have the values here. So what is happening? You are pivoting on season and batsman. So this is a pivot created on season and batsman, and your data revolves around this pivot. Okay, so for this you have the plot as well. If you remember, we plotted the bar chart using this. Okay, so this is for season 1 and season 2016 and 2015, and the which were the columns, the batsmen are your groups. So we have this format. We can do opposite as well. We can make the batsman index as well. So the plot will be different because you are taking batsman as the indexes. So now you have a data frame in which you are going for doing group by on few columns. Let's see it from the start. Let's say this is our data frame in which we have 3 columns A, B, C, and first we will be going to pivot on A and B. A is our index, will be our index, B will be our column, and C will be our value. So pivoting it will give us the error. Why? Okay, yeah. Index contains duplicate entries. Why? Because if you see the original data frame, 1A, 1A. So for 1A there are multiple values. That's why there is a problem, because the the problem is not that index is containing multiple values. Problem is that a there is a group violation. Like for a group 1A there are multiple values, 1, 0 and 9. So you cannot do the pivot here. Remember, for pivot you must have for each pair of column and index you are selecting. For example, A and B are your selection, so 1 and A should be just occurring one time. So the pivot is not this case, is not applicable in this case because the values will not be cannot be pivoted across A and B. But if you do group by, you can see that it works. You have done the group by on A B, so it gives you the B as the column and A as the rows. And what is the problem here? If you see the data frame itself, for 1A you had 0 here, and for 1A you had 9 here. So it just picked up the first value. It didn't care about the second occurrence. So for pair of 1A, you just have the first occurring value 0. So group by will work, but logically even group by is not correct because you used first. Otherwise, it will not be giving you any information because you need to apply first here because you want to just make it work using this logic that you want to pick up the first value only. So you will ignore that there is another repetition because for each pair 1A, 3B, there can be only one value for each pair in the resulting data frame. Okay, so now we are seeing that there is another way of doing this. If we want both the values, then how to get those? You cannot get both values in this logic because the purpose of pivot is not like this. The purpose of pivot is to, if you have, for example, a single value for each group, you maybe because you did some pre-processing on that. For example, in this case, for group of season and batsman, you calculated the total score for that for each season and the respective batsman. So there cannot be two ABD players with the 2 runs, where with the two total batsman runs for the same season. Yes, for a different season it can be possible because this pair is different than this pair. So logically, what how pivot works is based on this concept that you have single value for each pair. That's why that's why we can use this for bar chart as well because you just have one bar in each for each group, right? For 2015 and Virat Kohli, we have just one bar because we accumulated already. We don't want to do any operation again, so there cannot be two values. So the logic of pivot will not satisfy having two values. Yes, each pair and value should be unique. So let's resolve this error for pivot as well because you can tell the aggregate function yourself which is first. So you are telling that just pick up the first value. So it is the same pivot function but with the aggregate function mentioned that it is first. So this group by thing and the pivot thing is gone same in this scenario. So what does melt do is just an opposite to the pivot. It will, as pivot was converting your longer format to the wider format, it will just convert it back to the longer format. You can also read there and pivot a data frame from wide format to long format. So you have a data frame. Let's comment this out. You have a data frame like this. This is a longer for wider format. Actually, sorry, this is not a wider format. Sort of, it is a wider format. Yes, because you are using names as like column names, but this is not a very good example of saying that this is a wider format. But consider it a wider format. Like say, let's say yeah, that these are the names coming from. These are the names. These are the indexes. But you are saying that's why you are setting df dot set index is year. Then you are saying that dots just wait a second. We are making it more like this format, melting it down manually without using melt. So we saw that data frame. So now we are saying that our index is year. Then we are stacking. When we stack, after stacking, what we get is like this. I will show you. Like this. This is level 0. This is level 1, which was your columns. So after stacking, you said that I will reset the index, and before doing this, you can just see that like this. So if you remember this, you can see that this is just resetting the index like this after stacking. So now you have new functions in which you can specify the names of the melted format. So let's say you specify the name of this as value, and in the rename you will change the column names of level 1 as name, which is this level 1. So you can do it manually or you can do it using the melt. So the same data frame which we had here, let's see it before melting. This is our data frame and we are going to melt, and we are saying that on the ID of melting is year. So this year thing is considered as the melting point, and variable name is equal to name. So we are going to assign the name like we were doing it here manually. We are assigning in the melting function. So the transition is from here to here. You can just directly do melt rather than doing set index, then stacking, then everything. You can just directly melt, specifying what is your index variable. So id is index. So this thing is converted to this, and the var name is just the name you are assigning to your level 1, and the value will be automatically assigned the column value. So it will also do the same thing again. Like when you use call melt, it will do set index, in which it will give id as year. So for year, it will set index, then it will stack, then it will reset index, and it will assign the value which is by default by the melt, and then it will rename level 1 by name which you are giving here. Okay, so We have another example in which we have data frame like this. This is a wider format in which we again do the same process. We set index, then we stack. So what is happening? First we set time as our index, and then we stack, and after stacking, what happens? Part 0 and part heads become level 1, then we reset index. So again the level 1 we didn't assign name, so that's why it's still there, and for the value we didn't assign anything. But in melt we can do that. We say that variable name is part, and so it will replace level 1 by part, and id var is time, so it will be setting index on time. So next example is not from the stack or melt, it is from the regular expressions. So for the regular expressions, we will discuss that. So regular expression is like that. You have a specific format of an expression which you specify in a string, and you apply it to the strings. So for example, in this case, we are saying D is that number. D is for specifying numbers. We will see it in detail. Actually, the example is given before doing the thing. So for the giving the idea is like you are picking up the decimals out of the string. So when you say that part, which is this column, you are extracting what? You are extracting this, which is a number. So you are extracting the number. We will see the example in detail. It's just randomly put here to show you that what can be used of regular expressions. But we will see in detail the regular expressions. Okay, so the next thing is categorical variables. So the categorical variables are which are not the numbers. So for example, we have a data frame. We will be converting this categorical variables to the numerical format. We will see how to embed them, how to do the embeddings. Sorry, encodings, not embeddings. Correction. Yes, I can explain that again. I can explain that again at that. Okay, so no problem. So categorical variables is like when you don't have numbers, you have categories. So you assign each category a label or a name. So these names are called categorical variables. For example, you can say that A for values 0 to 1, 0 to 10, B for values 11 to 20, C for values 20 to 30. So these are categories. So whenever in your data you will encounter a value between A with 0 to 10, you will assign A or B, so on. So your grades are your categories. So now we will be looking at this format of data. For example, we have this data frame in which you have these categories. So let's say A, B, C. What we can do, we have a function called dummies, getting dummies. So to get dummies, it means that it will encode the data which was there. So what is happening is that you are applying on this column, which is column, again the name is column, dot str operation, and dot get. From str you are setting get dummies, and you are setting separator is comma. Separator is because there is commas occurring between each alphabet. So what it will do is like for it will convert it to columns. For example, A, B, C, D unique values for all the alphabets. So what are your possible formats? So AB is a single value because there is no separator between them, or it is considered as a single value. So A, AB, B, C, D. So what will happen for 0? A is there, okay, 1. Is there anything else? No, so 0, 0, 0. 1, A, B, C. So A is there, 1. A, B is not there, 1, 1. B, C is there. So this is sort of just setting 1 whenever there is a occurrence. So AB again is 1 because AB is there, but no other thing is there, so zeros. And then another example, you have airports data frame in which you have airports and their names separated by this straight vertical line. So if you get dummies, so by default the separator is this. That's why you don't need to mention this, that you want to separate on the straight line, vertical line. So it is also giving you the same thing, converting it to columns, then setting 0 or 1 whenever there is occurrence or not. So BHX is not there, so it is 0. Otherwise, for others, JAX is not there, so for JAX it is 0. Now we come to the next example, which is cross tabulation. Cross tabulation is concept of seeing the between the pair of values, seeing the occurrence of the pairs of values. For example, in this case, you will see the occurrence of Lexapro, Lexapro 1 and HD. How many times it is occurring? So Lexapro 1 is occurring just one time with HD. So you said that you are cross tabulating in between data frame 1, which is data frame ID, drug ID, and illness. So it will create a table between drug ID, setting drug ID as the index because drug ID is selected first. And the second option is giving the columns, which is illness. So the main function is this cross tabulation. So cross tabulation is like when Lexapro 1 with CD, is there Lexapro 1 CD? No. So it will give you frequency of all possible pairs in those two columns in which you have for which you have selected these two columns. So this functionality is called cross tabulation. You are comparing between two set of values, between a set of values from two columns. So now it comes to the text data in which you want to convert this you have the text data and you want to apply some operations on these. Why is it called vectorized string methods? These are because these are applied directly on the column, whole column. So it is quicker, and all the functions you have been seeing dot after dot str are like the column name dot str dot some function are all vectorized functions. Is it similar to pivot but with repeating? No, actually this is pivoting, but it is just giving you the number of occurrences. In pivot, you set the value yourself, right? But in this, This is a pivoted table. You can say that this is a pivoted table, but here what you have is just the values. So this is the concept of cross tabulation is using pivot, but it is doing something else. It is calculating the frequency and setting it to the value in that pivoted table. So this is just the frequency. So as you don't have any value table here, so value column here, so you just are calculating for the each pair, for each unique pair. But in case of pivot, you need to mention the values. But you are right, it is a very good point that is it close to pivot? Yes, it is actually doing the pivot after calculating this count. Okay, so these operations which we have been applying on STRs directly are all vectorized operations. So first thing to do is like we have this data frame and we want to convert the team column to upper. Upper is like uppercase characters. So str.upper will convert all of them to the uppercase. And then you can apply value counts. Still it is the data is not clean. You can see that. There are repetition of DD sometimes because of the cleanliness of data. But it why do we apply upper? Whenever we are playing with data which is text, we want to bring all the data in one format, either upper or either lower. So you can say that you have to bring all the data in either upper or either lower, because for example if it is dd2 and here is dd2, these are considered different if you don't convert them to same upper or lower format. That's why dd2 simply has 2, otherwise it would have been dd2 greater and upper format and dd2 and smaller format. But still it needs some cleaning, but uh, apart from that, uh, it is the first part of cleaning the data. So now what we are doing is we are moving towards cleaning the data. So mostly we have the text data and how to clean that. So these are sort of steps of doing that. So now we come to the another example which is using regular expressions, but regular expressions are coming in more detail here, but what I will tell you right now is that this regular expression is used for picking up the alphabets in uppercase, as A and Z are capital, so you are picking up the alphabets. So what you are doing is that you want to extract team names out of this where is it gone? Okay. Out of this very unclean data. So you converted them to upper. Now from these alphabets, uh, you just want to clean it. So what you said is that you applied that you only want to pick the alphabets rather than the numbers. So your data frame will become really clean, if you see. So how to apply these regular expressions in pandas? You just have this str extract in which you give your alphabets, like your regular expression. Sorry guys, I will just switch it to the silent mode. Advertisements. Okay, so Then there was another problem in the data. If you see there, the names are not separated by the spaces, they are separated by the underscore. So what we can do is just directly call df.player, which is the column, dot str dot replace, and we say that replace the underscore with the space. And we will see this. Before that, we will just see this. Okay, so let's bring our data frame back. Okay, so what is the chaining of the operation? We will see that. But before that, you need to see. I will come to your question. Uh, this is the first operation in which you just replace the values. We saw that it is there. But right now I have started again, so the underscore is there. Mm, So chaining of the operation is like when you apply one operation, so it is giving you a data frame, right? So you can of course apply another operation over it. So you can again call dot str dot title. So what does this title do is just make the first letter capital. So it's like that. And expand is for keeping the data frame intact. I will show you. Just wait a second. If you don't do this, this will return you the same data frame. Just wait a second. So as I was saying, it will return your data frame, which means that you are not actually, for example, this is itself a data frame, not a series. So it has an index, right? So this resulting thing is another data frame. But if expand is false, like this, then it is returning a series which you can assign to team name to the team. But if you do it true, it should still work. So what is the logical reason behind this? The logical reason behind this is uh, here in this case it returned a data frame when expand is true. So this data frame is a new instance which is assigned to df.team, which will of course replace the previous values. But when you don't have the expand as true, it will create a series, and that series is updated on the previous values. So your data is not you have don't have a new copy of the data frame generated created. So that series is the series which was already there, but you updated on the same series and returned it. But rather than doing that, you in other case you will have the data frame. But I think it doesn't matter a lot. But what we have to do is like, yeah. So you can see is like this. In true, it is creating a data frame. In other case, it is creating a series. You can do either of them, but it doesn't matter. Like logically, if you want it to be faster, then it should be a series, because data frame is created over a series, and data frame has index as well as column name, but series also have that, so it doesn't matter a lot. But it has its own metadata, and you are assigning a df.team again a data frame rather than assigning a series. So uh, again, this operation will convert it to the series when you are assigning. So it is just for uh, the execution time. When you have a lot of data, then it matters, but for a smaller data, it doesn't matter that whatever you are doing. But if you have a lot of data, then creating a data frame again is not fine, because it will be two steps. When you are will be assigning this data frame to the df.team, which is just a column, which means it needed a series. So this data frame will be first indexed for the getting the series, and then that series will be assigned to this. So this is two steps. Otherwise, in the other case, if you are just returning a series, then this df.team will be assigned the series directly. So the thing is like, the speed difference might be just few nanoseconds, but it matters. Not nanoseconds, actually, milliseconds. But what matters is that when you have a lot of data, then you have to care about these things. So the basic difference is it returns, if expand is false, it will return you a series. Otherwise, it will return you a data frame. And to remind you, the each column itself is a series in a data frame. Is it clear or not? I think is it clear? Yes, okay, that's good. Uh, then you have the split, but we saw split before, but splitting with this, the thing is like you have a data frame again, so you want to split on the space, the sorry, yeah, you want to split the name of the players, and you are considering this data frame actually, this data frame format. You want to split the first name and the last name of the players. Now expand is false again. So you don't need to mention it actually, because expand is none is considered false right now. So why didn't it work? Because you didn't specify the splitting criteria. Splitting criteria is my mouse is this. Okay. Oh, I removed that. So let's say you have this data frame and you want to split that player name. So Virat and Kohli. So you have to split two times, because for str0, you have to pick up the str0, which will be Virat on this split, and you have to str1 as well, which will be Kohli. So you are assigning a new column, a first name with the str0, which will be Virat, and str1, which will be Kohli, to the last name. So all of them are given the same thing, are updated, and then you are dropping the actual player column, which was this combined name, and setting in place true, if you guys remember, is when you don't want to assign the data frame again to a data frame, to another variable or the same variable, so it will be updated itself in the data frame. So guys, now we will take a break, as I need to drink some water, and but you can ask the questions if you have any until now. Then we will continue with the regular expressions. So let's have a break first for 9 minutes to be precise. start recording again. Okay, so now we have to start regular expressions. They are really important when you are handling string related data or text data to be precise. And uh, for regular expressions, there are several sort of things which we need to see first, and which are first there are some identifiers of how much data you have to pick. So let's say static or star if it is for 0 or more, like any number, any possible number occurrence. So why there is a star if you have 1 or more? Because you want to say, for example, if you are want to exclude something. Sorry guys, there is some noise. Okay, so if you want to exclude something uh, out of a string, then you can say that if it has 1 or more occurrence and so on. So the use of this thing is not much in our case, because we just want any occurrence, or one more occurrence will be both same for us. So but the cases in which you want to select, there it matters sometimes, but for us it is sort of same either of them which we will be using, because we just want to update the strings. We don't want to to be selective at any time. So for updating the strings, you can use either of them. So this is the same thing like before. So plus 1 or more, as this is for space, and this symbol is, sorry guys. This symbol is for space backslash s, and plus means 1 or more spaces, and this means 3 spaces. So this is the number of spaces you are identifying. And this is for all the alphabets, A to Z and smaller a to Z. But this is for, actually I have a problem with my mouse, so uh, this is for all the alphabets including the space. So in this case you are not including a space. We will have more overview when we will have more like some examples. So for selecting numbers, you are going for numbers, then okay, then you choose using d plus, which is backslash d is a decimal, you can say. So you can pick up all numbers or you can exclude all numbers. So for alphanumeric, you need to use AZ for smaller and 0 to 9 in the same place. Or you can go with alphanumeric like this, with a smaller w, backslash, and plus either this or this. So this is a short version of the same thing. And this is good because if you put a capital W, then you can exclude the alphanumeric. So you are expecting special characters. Let's see some examples first. Uh, for example, you have a data frame. So this data frame is like this. You have players and teams. So in the teams there is some messy data. So you want to pick up that. But in the first example, we are going for player names. We are making two columns, first and last, and we are the one more thing about this is the same thing we did with split, but but now we are going to do it in a faster way. This W backslash W is alphanumeric when you have this case numbers and 5. So you will be ignoring special characters. Just it will return you DD2 rather than DD2%. So in this case it will be 4 KKR3. There will be no at the rate in this symbol. So it is just for picking up alphanumeric. Alphanumeric is like when you have alphabets and the numbers together. Is it okay? Like this case, dd2% applied with uh, w plus will give you dd2. Okay, so the case is above, and now we will have another use of expand here. We will see how it works. There is a uppercase W plus as well, which means you will not be including alphanumeric. So this will return you uh, only the special characters. So dd2% uh, W capital W plus will give you percent. So this will give you special characters actually, the capital W one. Okay, so there is an example in which we are picking up player names and we are making the two separate columns for them, but we are looking at the same thing we did with split, but it is a little bit different. So what you are doing is that you are specifying there is an underscore, pick up everything before underscore, pick up everything after the underscore. So what this will do is like you have put a bracket, so it will give you everything before underscore as one element and everything after underscore as another element. So here underscore became a separator. How? Just by specifying through these brackets, pick up anything, any number of occurrences. So here if you put a plus, it means that there should be at least one thing, one character after the underscore. But if you say star, then in this case it will work because you can have any number of characters after the underscore. Maybe Virat underscore didn't have anything after underscore, like Virat underscore. So in this case, dot plus will not work because it will not give you anything because there is nothing after the underscore. But for a static, as you can have zero or more occurrences, even Virat underscore and after and nothing after that will work. So this is just one instance, this is another instance. So this will give you two separate things. But we set expand is equal to true because there is we want a data frame and we want to assign data frame to two columns because series cannot have multiple columns, right? So that's why we want a data frame. So that this is going to be correct when we will return a data frame. So now you see first and last. So Virat Kohli is separated. Remember, when you are returning multiple columns, you need to specify expand is equal to true because series is just one column. There is no multiple columns in a series. And the thing with this is that when you return this data frame, you just assign it to two columns because two columns can occupy two column data frame. Now you are going for team code number from team column. You want to extract this number. So simply you can say that d plus and it will give you the numbers. Okay, so what is the case here is that, just wait a second. Okay, so the simple case here is you asked for the numbers, but you didn't specify any format of the numbers. So the it will get the number until there is a number, but it will just pick up the one number. For example, here it will pick up 4, not 3, so it will not be 43. So if there is anything between the number, the number which was the first one is picked up. So how to carry that, how to work with that is just use another regular expression, and which is, so here what you are doing is you are excluding the alphanumerics out of alphas out of the alphanumerics. So this is for excluding. So this is what it is doing, is that excluding the alphanumerics, alphas, excluding the alphas. So and sorry, this was the and the special characters, because this is a capital W. So this is excluding alphas and special characters and replacing it by a empty string, which will be, this will result in 43 because special characters are removed. So if you see them separately, uh, there is another symbol for exclude as well. I will come to that if there is an example. So here you are not excluding your special characters, but you can exclude them using and. So this is the and operation of special character, because this is a capital W, if you can notice. So alphabets and the special characters are removed. How? By replacing it by a simply a empty string. So this will give you the whole number you wanted, rather than giving you just the first number, which was the case in this. Now what you want to do is, like, you want to extract from player column here. So from player you want to extract the alphabets. But what is the problem here? Is that the problem is this, like, you are not again getting all the alphabets, because this is just giving you the alphabets until the space. If you do this, even in this case, wait a second. Okay, so is there a simpler way to exclude? Simpler way to exclude. Let me. I don't think so. There's a simpler way to exclude, because in regular expressions you need to specify in a very, like, in general regular expressions are converted to graphs. So these graphs are on which the string is passed through. So the there need to be, like, for if you are using regular expression, you need to specify each thing in a proper way. So it will be like one node of the graph is A to Z, and another node is WV and W. So it will be like, first it will pass through the strings. So if I create here, so let's say, don't know what is wrong with the mouse actually. So let's say I will come here. Let's say you have a graph with two nodes. Your input is like this. This is your output. So what is happening is, like, here you are applying the first operation of getting alphabets, then you are applying uh, of getting special characters, then it is your output. So after getting that, them you just simply go and replace them using the string operation. Just wait a second. Actually, there are a lot of symbols, so let's see if the simpler way can come in. So where is it? Here. Oh, that's the problem actually, because usually regular expression has different symbol in different languages. Regex exclude character. No, try this. No, I will look into it, but mostly what they do is like even if you see here, they apply a string operation later for subtracting it. So subtracting is like ex exclude. So the regular expressions are mostly like they have the exclude character. I am not remembering what exact the character was, but usually what they do is like uh, just pick up the thing and subtract or replace or remove it from the actual string. So I will look into it if there is a exact character for that, because usually these operations are like bin binary operations, so they are like and or, so there should be a not as well. Okay, so we were where we were. So here you are extracting all alphanumerics, and in this case you are getting the alphabets, but they will be until under like until there is a special character. So if we put the special character within, so it will give us the whole alphabet, but we don't want that, so that's why we are getting this. If we want both of them, then we can do this way, like there is a element here and there is a element here, so pick up on the basis of a underscore. Okay, so then we pick up the alphanumerics using W plus, smaller W plus, and then you have a capital W plus to extract special characters. but we will have none when there is no special character. So there was a no special character in this case. So there is a none. Then in the two cases you have the special characters, and you will just get the first one. Okay, so now we have another example in which you have the extract all method. Here it was giving us the first match, so extract all method returns every match. The result of extract all is always a data frame with a multi-index on its rows. The last value of multi-index is named match and indicates the order in the subject. So it will give you a whole data frame out of a single column, just giving you the information of these matches, like how these things are matched. So let's say you are saying I want a number and anything between it in between, then I want alphabet, then I want another entity which is again a number. So let's print that. So it will give you uh, all the matches, like with the separators you have decided. So the first thing is your number, the second thing is your alphabets, and the third thing is your number again. So the first column is your numbers, and if there isn't a number before the alphabet, so there is no column, there is none. And if there is a number after, then there is another column for that, which is 2. So the order is 0 because every match is just only once. For example, this will be matched again, then it will have a match value 1. We will okay, now we have first name last name example with extract all, and we want to reset index after until level -1. So all the text is reset. So what happened now is like we wanted a name before underscore and after the underscore. So first name, last name, the same thing is done here, like before. So this is another way of doing it. Here match is the number of occurrences. No, it is just the order of occurrence. So this is the 0th match for each case. If there is a repetition, then there will be 1 for that case. So this is just the order. It is not the number of occurrences. That's what you are confusing here. For example, there is a 100 RCB5, then there will be another 100 RCB5, then there is a match 1 as well for that. Okay, so this is another example of using extract all for the same example we did before. First we had first and last using this. Now we have extract all to do the same thing. Why did we reset index? To like drop the index which was match. And there is a function called contains, string contain, which will tell you if there is a value, specified value in there or not. So if you see the Boolean indexing, if there is a string in a team or not. So there is a, sorry, what? Okay, so we were at the contains. Uh, if there is a string in there or not. So it will give you true, false with respect to each team. So the false is where is at 3 because it doesn't have any small alphabets, lowercase alphabets. So we are looking for lowercase alphabets. So for all cases in which there is no lowercase alphabet, it will be false. Then you can use this to index easily, and you are just picking up the lowercase alphabet rows. Okay, so I think we should stop here for the regex because it is a huge topic, but we will like repeat this thing again a little bit because I think the pace was a little fast, so I can repeat it again. So that's not a problem. But what you can do is like you can try to do this week's assignment. And about regex is like you just need to know these symbols, but the exact way of picking up the data comes when you are like doing more and more examples, because there are a lot of cases in which you can apply regex and a lot of ways you can apply regex. So regular expression is like for one person maybe it is different, for other one maybe it is different, so it can have different logics. So like someone suggested, how can we exclude something in a different way? There is a different way of excluding. Maybe you don't need to replace in that case. So, and you can even subtract rather than replacing. So there are a lot of cases. So for the thing which is left, just wait a second. I will come back to the slide again. I have to show I have to discuss the stack and unstack again. So guys who are fine with that can just wait a second. Okay, so first here is feedback. Then I am repeating the stack for an unstack. So if you guys are like you already are okay with it, you can leave. So as the session is over, but we will be repeating it again. And guys, give the feedback and mention in the chat that you have given the feedback because it is important. And so what do you want me to repeat? Anirudh asked me to repeat this. Yes, tag and unstack. Okay, so I will repeat it. In the meantime, uh, please give the feedback and pivot. Okay, so stack. The first thing is stack. So for example, you have a data frame like this in which you have some columns and your index is your some text values, so integer strings values. So what you can do is like you can just stack. So stack will do is like it will take your columns and it makes it as a multi-index. So one will be your first index, first level index, and id will be your id and value will be your second level index. So if I show you the stack thing here, it will be like this. So this is like this whole is your index. This part is your index. So this is your level 0, this is level 2, level 1. So for 1 you can have id and value, for 2 you can have id and value. So for all it will be like this. So even if there is a 3, then 3 id and value. So this is a group, this is a single group. Oh, sorry. Okay, so this is a single group of values. So you can have some output related to them. So this is what stacks do. Stacks the indexes. It is not like the horizontal or vertical stack we discussed before. So this is stacking and stacking the indexes. So when you reset the index, it will be again plain, and in this case you can see that it has renamed level 0, which was your 1 2, level 1, which was your columns, and 0. So this is like just resetting the index. So the index can be 0 1 2 3 4 again. Now we create a series with using the multi-index. Multi-index is like, again, as we saw before, is like you can have multiple levels. So same example like this one. So here in this case you have a series with multi-indexing. One AB is one group, two AB is another group, and you have some values related to them. So what does unstack do? Unstack will bring it to the to this format, because it brought the data to multi-indexing in the other format. So it will be just like 1 2 is your index, and AB was the second level, so or level 1 is brought to columns back. So stacking is like stacking the indexing and stacking the indexes using the columns. Now unstacking is the reverse. So it is like two-way operation. You can say that uh, stack generates multi-indexing based on index and columns, and unstack just bring back the columns. So pivot is for converting the data to the wider format. What does nb.arange? It is nb.arange is like you are generating values from 1 to 5. If you remember from the second session, it is like 1 2 3 4 5. 1 2 3 4. 5 is not included, that is the maximum limit. 1 2 3 4. This is a numpy function. It's like if you have used range in simple Python, then np.arange is the same thing in numpy for generating numpy arrays within a range. So np.arange will give you like 1 2 5 4 values, 1 2 3 4. So now we come to the pivot. The pivot is as I discussed before, first thing, if you say it theoretically, it is used to convert the data frame from longer format to the wider format. So the longer format is the one in which you have like this data. But what does pivot do? You pivot on the base of like you choose one column as your index, and you choose one column as your columns. So your data will be pivoted around these pairs. So when you choose one column as your rows and your index, and one column as your columns, it means that you are making pairs. So these pairs are here. For example, for season and batsman, pairs are like this: 2016 AB de Villiers, 2015 AB de Villiers, and so on. So if you pivot around these two, this will mean like this. If I highlight that and comment out this, so you are telling that your index will be season, your columns will be batsmen. So this will be a collective pivot. This whole thing is a pivot, and your values will be batsman runs. So this is your wider format of the same data set. So you can see that it is a different representation of the same data set, data frame, and the advantage, one similar like one evident advantage is that it is more representable than this one, and you can easily plot based on this as well. So columns will be taken as the class groups. Similarly, if you would go in the opposite direction, like you pick up batsman as the columns, as the index, and the season as the column, so this will be the other way around. So pivoting is like picking up a set of columns. Set is like two value set. So a pair of columns to show data around. So this pair of column, the batsman column and the season column, will be used to show some values. So these are the values based on these pairs. Similarly, yes, it is respect to only two columns. It is respect to only two columns. You are correct. And pivot, we are at pivot. Okay. So then there is another example where pivot gives an error. We discussed it because as we saw that pivot can have each pair in a pivot can have unique value. So there should be no repetition of 2016 and ABD values. So in that case, pivot will give you an error because there is a repetition. Oh, sorry. Here. Here is an error because there is the problem is with the uniqueness. But you can of course group by to fix this problem, but you also said that we are picking up the first values only. First occurrence. So we can also fix the pivot using the aggregate function first. So the first means just pick up the first occurrence, which is 0 in this case, if you see 0. And the other occurrence was 1A9, which is not taken. Unmelt is just to unpivot the data. So data frame. So you pivot converts it to the wider format. So what your melt will do is like it will convert it to the longer format again. So we have some pivoted data here. So we don't have the name of the columns which are there, but this is the pivoted data. So what we can do is we can melt in two ways. Sorry guys. So first you need to set index. Which column is your set index? Here you said that it is the set index. Then you say stack it. When you set the index, you will stack means that you will have multi-indexing. If you see until here, here you will have multi-indexing, right? So the stack will convert the columns to what? Your second level index or level 1 index. So for year you set it to the index, then you did stack. Stack means this. Then if you see reset the index, it will simply convert it to the sorry guys. So it will convert it to the melted column, melted data frame. And similarly, you have another data frame, another way of doing the melt, which is direct, in which you just specify which column is your index. So this column, in which you are setting the index, and the variable name is just to specify the name you will be assigning to the new column which will be created. Is it clear? It is a little bit confusing. Yes, this concept is, but what you need to do is like you need to see like you need to see it step by step again if you are still not clear, because there are like four concepts which are merged together. There is stack, first thing is like stack and unstack are opposite to each other, and melt and pivot are opposite to each other. So if you do pivot, then melt can be used to unmelt it. So unmelting is like uh, basically converting the same data frame which was in the wider format to the sorry, to the longer format.